I'm in the middle of working on a new philosophy of mind book. Actually, sort of tongue-in-cheek temporary title is Tractatus Cognitio Philosophicus.
Oh
So
man,
it's
that's
just a
good.
sort of a pompous joke on Wittgenstein,
Good.
who had the Tractatus Logico
Yeah.
Philosophicus, which was itself a joke on Spinoza's earlier work, which had a similar title, right? My goal in the new Tractatus is to write a philosophy of the mind and universe, which can be read by an early stage AGI to shape its thinking about intelligence. You suck it in to the early stage AGI's knowledge base. Now it can then rewrite and revise everything you've told it, but you're seeding its conceptual self-organization. If you have an AGI system that has an explicit logical reasoning component to it, along with neural net components, for example, which is what I'm doing with my OpenCog Hyperon project that we'll come to, then part of the seed ontology that guides the AGI's learning can be, explicit logical theories of the world, right? So
Yeah.
then you can take your philosophy of mind and you can feed your own goofy half-baked philosophy of mind and feed that into the AGI's mind as explicit logical content into the
Hmm.
logical portion of its sort of multi-component mind. But then, yeah, Tractatus Cognitio Philosophicus, it's designed for human consumption, but also largely for the AGI's consumption.
Hey, welcome back to another episode of Parker's Pensées. This is a podcast where we explore all the deepest ideas in philosophy, theology, nature, and life. I love thinking about cool stuff, so come think with me. Today's episode is very, very special. I have with me Dr. Ben Goertzel. This is a dude I've been wanting to get on the podcast for years, since I started the podcast. He is a philosopher of mind. He holds to a particular theory of mind called patternism. He's written books on it. He's an AI theorist, artificial intelligence theorist. He helped popularize and coin the word, the phrase artificial general intelligence, which is what you think of in sci-fi, a AI, a robot that is generally intelligent, that thinks the way humans do, a thinking machine, not just a specialized AI like we have today. He's also like an AI engineer. He was, I have all his stats here, and there's just too much to even look at. Um, Okay, so he was the chief scientist for Hanson Robotics. That's the Sophia robot. Some of you have seen on my social. I got to meet Sophia the other day. He made the algorithm and the software behind Sophia, which is fantastic. They're creating a metaverse called the SophiaVerse. Like, this dude is a sci-fi genius, like from a sci-fi movie. I love this guy. He's really fun to talk with. I think we probably disagree a lot philosophically, but I don't really care. I just want to hear him talk. So this episode is really fun. We go in deep on like trans nihilism, different views of the world. Are we in ultimate reality? One of the questions I asked him was why spend so much time working on AGI and not a metaverse? What's the deal? Like which one has more leverage and why? And he explains. So we go all over the place. We didn't quite get to consciousness, but that's next time, and he's going to come back on. He's also writing a philosophy book to train his artificial general intelligence on philosophy. So that's pretty wild. I'm really excited to see that book. He said he's going to come on and talk about that one as well. So I'm just super duper excited. I hope you guys like this one. If you like the podcast, please consider supporting it on Patreon or on YouTube members. Wherever you're getting this at, you can find those links in the description. You can find merch. There's a bunch of different ways to keep these lights on, to keep me able to feed my dogs and able to get top-notch, world-leading scholars like Ben Goertzel on the podcast. So without further ado, let's bring in Dr. Ben Goertzel and let's talk about artificial general intelligence. All right. So Ben, thanks for coming on the podcast, man.
Yeah. Thanks for having me.
Yeah. So I've had some unsupervised learning on lots and lots of Ben Goertzel material, but now I'm looking to have some reinforced learning with Ben Goertzel in the loop, with some Ben Goertzel feedback. So before we jump in, I got to ask you something. Are you an AGI yourself?
Well, that depends on the definition of AGI, which is one of the things we're going to dig into, right?
Sure. That's very true. I just didn't know if there was like some kind of grand prize if you had been an AGI from like a previous Ben Goertzel, and maybe I win like a golden ticket and you give me a chocolate factory or something.
Well, you've seen Terminator, right? I mean, there's a possibility of AGIs coming back in time
Yeah,
from the post singularity to help facilitate the singularity's emergence. So
that's right.
I can neither confirm nor deny such rumors.
That's good. Well, that was actually one of my other questions was if any time travelers have been showing up trying to assassinate you or Rachel Sinclair recently.
No, they've mostly been very helpful, friendly, and benevolent time travelers.
That's great.
We've been fortunate.
Uh, that's so good. Well, for the audience here, here's where I'm hoping to go. It's kind of a large task. I don't know if we'll get there all the way, but I'm looking to talk to Ben about what is AI and what is AGI, why someone might want to make AGI, three promising ways one might go about making AGI, including Ben's view or Ben's current project, Hyperon, and then asking some questions about his patternist philosophy of mind and whether or not Hyperon could be phenomenally conscious in the future. So, Ben, this is awesome, man. We met at Mindfest 2023,
That's right.
but
Yeah.
I'd first heard of you on the Lex Friedman podcast, which I still think is probably one of his best episodes ever. And I think that partially because I was taking a break from writing my master's thesis, and I was listening to you and him talk, and you started talking about Mikhail Bakhtin and polyphony, and it
Yeah.
blew my mind because I was writing my master's thesis on Mikhail Bakhtin's interpretation of Dostoevsky's authorship. So I was like, man, this is crazy. I knew I was going to like you. Um, so I want to talk a little bit about that. But as I've come to learn more of your stuff, I've read some of your books, read a lot of your papers, and listened to your podcasts. And I keep getting like this, like Kevin Flynn vibe from Tron. Are you familiar with Tron? Have you seen the Tron movies at all?
Tron. I did see the movie Tron way back. Yeah, that was like the first 3D graphics movie
That's right.
ever, right? So I saw it in the theater when it first came out, but I haven't thought about it much since.
That's awesome. Well, he's like a real smart dude, but he's also really chill and cool. And it's like you, man.
Yeah.
Like you're super smart, but then you're like super chill and cool. And so as I'm looking into this stuff more and more, a lot of the people who remind me of you, at least in movies, they all work on metaverse stuff. So I wanted to see like why not go in for like a digital world instead of making AGI? How'd that happen?
So I became interested in AI really in the early 70s when I first saw robots on TV and robots in the original Star Trek with Kirk and Spock and all that. And
Yeah.
I remember an early Star Trek episode where there was some defective, buggy AI robot zooming around the galaxy, wreaking havoc. And Kirk and Spock basically destroyed it by tricking it into a logical paradox, which caused its circuits to fry. And I must have been like 3 or 4 when watching this, but I was like, this makes no sense. Like if people can deal with logical paradoxes, like why couldn't this robot? It's just another hunk of matter of a different kind. So I didn't buy it that they could build this amazing robot, send it around the universe, but they couldn't, teach it to reason about X equals not X, right? So, but that got me into science fiction AI, and it didn't take long, even as like a preschool age kid, for me to come to the conclusion, like once you made a machine smarter than people, that machine is going to invent things smarter than it and more and more and more amazing stuff, right?
Right.
So it seemed like that's the master key. Once you've created the AGI, if the AGI likes you, then that solves all the other problems too. And
Totally.
there were many other things that are interesting and exciting to me. And I mean, I read a little later than that, when I was 10 or 11 or something, a book called The Prometheus Project.
Yeah.
By a Princeton physicist, Gerald Feinberg. He said in the next few decades, we're going to create machines smarter than us. We're going to create nano machines that can create any form of matter we want. and we're going to cure aging and death. And the question will be, what do we do with that? Do we promote rampant consumerism, or do we expand consciousness, or what?
Yeah.
And is this controlled in a democratic way, or is this controlled by an elite, right? So that was all laid out in Feinberg's book from the late 60s. I read in the mid 70s. We didn't have the term singularity then, but basically it was the current vision of the singularity. But it was clear of all the ingredients there, AI had the most potential to sort of facilitate all the other things happening. So, of course, virtual worlds are really cool. I mean, post singularity, most life is going to happen in engineered, simulated realities rather than, and it, let me say, is going to be in realities that are known to be engineered and simulated. The reality we're in now may also be, but we don't have solid knowledge of that, right? So it's going to occur in explicitly engineered virtual realities. But why not work on virtual reality and metaverse instead of AI? Well, once you got the virtual reality and metaverse, that may facilitate emergence of AGI, but it doesn't build it for you. Once you build the AGI, that can build the metaverse for you, right? So it's got the most leverage. I mean, it also felt like the most fascinating intellectual puzzle to me, right? Sort of the recursive aspect of being a general purpose mind that figures out how general purpose minds work. That seemed like it's an even bigger puzzle than like unifying general relativity and quantum mechanics, or building time machines, and certainly a bigger puzzle than the fascinating, difficult technical issues involving in building metaverses. I mean, although those are thorny issues also, but I think all these things are going to come soon. So we live in an incredibly, bizarrely exciting time, right? Where we can look at, I mean, we can wonder about, is it going to be 3, 5, 8, 10, 12 years till we have machines smarter than us? And after we have machines smarter than us, you know, is it going to be 6 months or 5 years until they create machines that are massive super intelligences? So there's details on the path that we don't yet know. But I mean, the fact that these things are years or even decades away by a solid, you know, rational scientific analysis, rather than centuries or millennia away, or, you know, impossible. I mean, that's pretty incredible, right? And that's fascinating time to be working on this stuff. But I would say my idea to focus on AGI as the sort of point of the most leverage in the spectrum of amazing advancing technologies, it seems even more apropos now than it did in the 70s or 10 years ago. So I mean, it feels like it was the right guesstimate of what to focus on.
Yeah, seriously, big time. Well, so I read a bit of The Hidden Path, a patternist philosophy of mind. I'm studying to be a philosopher of mind, so I was really fascinated by this. And in there, you mentioned trans nihilism, or what you called Philip K. Dick's semi-reality, and we share a mutual love for Philip K. Dick. I wore his "Do Androids Dream Electric Sheep" here. And I wondered if trans nihilism, so it's just this view that like the world may not be objectively real as naive realists maybe take it to be. I wonder if that. Yeah, go ahead. Yeah, please.
So I've been heavily driven by philosophy of mind since I first encountered it as a teenager, I guess. I mean, my first forays into AI were more driven on the physics and computer science side.
Okay.
But then it quickly seemed that like we just didn't have enough solid knowledge about either how the brain works or human cognition works. Like there's solid knowledge about some things. We had a lot of knowledge about the hierarchical neural nets behind computer vision. You know, we had mathematical logic that told us something about very abstract thinking. But there are many, many gaps in our understanding of how intelligence works based on science. And so that then how do you fill in those gaps, right? And philosophy at least was trying, right? It was
Yeah.
trying to come up with some conceptual framework for how the mind should work or must work based on, you know, principles of coherence and sense, and
Yeah.
based to some extent on introspection when you get into phenomenological philosophy. So I first got into philosophy of mind sort of trying to figure out how to fill in the gaps of what science told us about how to make thinking machines. Of course, after a while, philosophy also becomes its own end, because just trying to understand everything at a foundational level
Yeah.
becomes a goal in itself. Now, the hidden pattern I wrote in 2006 as a sort of summary of a bunch of philosophical works I'd written over previous years. So there's a more recent lengthy paper I wrote, which is called Uri Physics, EURY Physics, which summarizes some of my more recent thinking on the philosophy of the mind, the life, the universe, and everything. And actually, I'm in the middle of working on a new philosophy
Wow.
of mind book, actually, which is a sort of, the tongue-in-cheek temporary title is Tractatus Cognitio Philosophicus.
Oh
So
man,
it's
that's
just a
good.
sort of a pompous joke on Wittgenstein,
Good.
who had the Tractatus Logico
Yeah.
Philosophicus, which was itself a joke on Spinoza's earlier work, which had a similar title, right? So, but
Yeah.
my goal in the new Tractatus is to write a philosophy of the mind and universe, which can be read by an early stage AGI to shape its thinking
Mm.
about intelligence. So my first thought was to write it in predicate logic form, or
Yeah.
in Lojban. So you're writing a philosophy of mind in a logical form,
Right.
then you suck it in to the early stage AGI's knowledge base. Now it can then rewrite and revise everything you've told it, but you're seeding its conceptual self-organization process.
Yeah.
Now, with advances of large language models, what I think, you can just write it in English, and for some portions of the text, I will give an explicit translation into formal logic, just to give it a clear clue of the style in which I want
Yeah.
these philosophical pronouncements to be translated into logic, and then let the AI do the rest of the translation into logic to feed
Hmm.
its reasoning engine. But I mentioned this because it indicates, I do think coming to a conceptual understanding of the mind and world is important. And of course, AI systems need to learn from experience, right?
Yeah.
And
Yeah.
I mean, an AGI, an artificial general intelligence, a system that can generalize beyond its training and its programming. It learns how to be an AGI in part by trial and error, and by guided trial and error in interacting with other minds. So
Yeah.
learning from experience is a key part of a worthy AGI architecture becoming an actual operational AGI.
Yeah.
However, humans learn from experience in a way that's seeded and guided by our brain structure, right? So
Hmm.
it's the old dichotomy of nature versus nurture obviously is very oversimplistic. I mean, there's self-organization, which happens in the humans in the fetal brain already. So there's nature and nurture. Then there's environment modulated self-organization. And there's also the fact that nature largely takes the form of structures that bias nurture and
Right.
self-organization in a probabilistic way, providing some guidance to that self-organization and nurtured learning,
Yeah.
rather than nature like programming exactly. So I
Yeah.
mean, the
Handcrafted
syntax of,
knowledge. Yeah.
yeah, the syntax of language is not there in the brain,
Right.
but nor is the brain really learning language from nothing. An inductive bias to learn certain sorts of syntactic and semantic structures is encoded in the brain, which is why we're biased to learn certain sorts of languages, right? So, but when you're building an AGI, what sort of bias does the AGI get? Well, there's the bias implicit in the initial algorithms and data structures that you give the AGI, which it then may ultimately rewrite if it's a sufficiently, reflectively powerful AGI.
Yeah.
But you can also give the AGI a sort of seed ontology, and we have a seed ontology built into our brains in various different ways. Like we have certain ways of reacting to mom and dad, which are just wired in. I mean, we have, the hippocampus has a top down visual view of the world in its place cells. The parietal cortex has face-centered and eye-centered views of the world built in. So the linkage of this top-down and this first-person view of the world, and the fact that you can convert back in between them, like this is part of our seed ontology wired into our brain. Now, an AGI's seed ontology doesn't have to take exactly the same form that the human brain seed ontology does.
Right.
So if you have an AGI system that has an explicit logical reasoning component to it, along with neural net components, for example, which is what I'm doing with my OpenCog Hyperon project that we'll come to, then part of the seed ontology that guides the AGI's learning can be, explicit logical theories of the world, right? So then you can take your philosophy of mind and you can feed your own goofy, half-baked philosophy of mind and feed that into the AGI's mind as explicit logical content into the logical portion of its sort of multi-component mind. The important thing is just you let it revise this content however it wants and refute every idea you gave it based on its own experience. But you're still seeding it with this process, right? You're still seeding it with this content. So I have one more recent philosophical work than the hidden pattern, which is Uri physics, which was a paper published in the Journal of Non-Locality, which you can find online. But then, Tractatus Cognitio Philosophicus, it's designed for human consumption, but also largely for the AGI's consumption. So going back to transnihilism, which is a goofy term I coined when I was 17 or 18 or something. I mean, probably someone else came up with it first, but that came out of Nietzsche more than anywhere else, actually, because I mean, like many precocious antisocial teenagers, I fell in love with Friedrich Nietzsche in my late teens, right? Because he's like the ultimate eternal teenager nonconformist who's saying like nothing is true, everything is permitted. Like don't believe any of this shit these people are telling you. The world doesn't exist. Right. Don't be a wimp and like forge your own path, right? And I mean, it's a great message. I've fully absorbed it in my teenage years. Of course, I have a different view on Nietzsche now. I mean, I think he was a very deep, profound, amazing thinker. He was also very immature and silly in some ways. And I would love to go back, compliment him, slap him on the face, and have a deep conversation with him. Right?
That's awesome.
But I mean, if you look in the third book of The Will to Power by Nietzsche, or The Twilight of the Idols, some of his later works, I mean, he was putting forward a point of view where first step is you realize there's no solid reality. There's nothing that's definitely known. Like everything is in some form an illusion bolstered by other parts of the illusion. And right. I realized this very intently when I was 15, the first time I dropped acid, right? Like then you can see it very vividly. Like all these things you took for granted is real, like your own self and the physical world. These are constructs that are constructed by a web of other constructs, which is what Buddhism calls the web of Maya, or however you pronounce that Sanskrit word. And Nietzsche portrayed very, very clearly within the will to power. He said all there is will to power and morphology and nothing besides, right? Morphology is pattern, it's form.
Yeah.
All you have is a network of patterns giving rise to and bolstering other patterns and trying to realize themselves and get themselves recognized by yet other patterns, which is the will to power aspect, right? So the trans-nihilism aspect means pushing beyond the idea that nothing is absolutely real and realizing, as Nietzsche said, we must each construct our own law tables and our own values, right?
Transvaluation of value.
Nothing is absolutely real, but on the other hand, you can make your own reality, which has its reality within your own context and scope. And that's how you build stuff. That's how you build yourself. And that's in Nietzsche's view, that's what makes you the Superman, right? The Superman creates his own self. He creates his own value system and creates his own world. And then he contends and collaborates with others who are doing the same thing.
Yeah.
Now, he didn't have a clear path to get from man to Superman, but he clearly saw the idea. And it's not a coincidence that a lot of transhumanists like Nietzsche, right? Because in essence, with building AGIs and cyborgs and mind uploads, in essence, we have the ability to realize what Nietzsche was looking at when he talked about the Superman, right? I mean, we also have the ability to go beyond man and woman, for that matter. It becomes really a super mind and a super system, right? But I mean, you have the ability to have reflective, self-creating systems that can rebuild themselves and create their own values. Actually, while we're talking about nihilism, I actually have on the wall of my office here a picture of the early Russian nihilist Sofia Kovalevskaya, who was one of the pioneers of mathematics and the theory of differential equations. But she also wrote a book in the late 1800s called Nihilist Girl, which was sort of putting forth the theory of Russian nihilism in a character and fiction form. But what's interesting, if you look at what Kovalevskaya and the other Russian nihilists wrote at the time, is the nihilism they were pushing forward was not the kind that was parodied by Dostoevsky. So
it was like Bayesianism or something, right?
Yeah, Dostoevsky was he's a genius. He's a religious fanatic, and he was like making fun of the nihilists because they didn't believe in God, basically. So the nihilists were really saying you can't know anything absolutely. They weren't saying that you can't, from your own subjective perspective, have some probabilistic knowledge, right? And Dostoevsky sort of parodied them as people who believed nothing, so they were totally confused, running around like headless chickens, which was funny. And because he was such a good writer and so good at drawing characters, his parody of the nihilist movement had more lifespan than the actual ideas of the nihilist movement, which is funny. So eventually, I realized what I meant by trans-nihilism was not too far off from what Kovalevskaya and the other actual nihilists were putting forward, right? It was kind of beyond Dostoevsky's parody of nihilism, because the original nihilists didn't actually think that nothing had any greater meaning than anything else from any perspective. I mean, their view was more like, don't believe people who tell you this is the absolute truth. Like make your own truth, right? And
more like perspectivalists than
That's right. So I hope we can resurrect all these people once we have an AGI. So go back and like reverse engineer. So based on the writings from Kovalevskaya, Nietzsche, Dostoevsky, based on their writings, and what we know about human brain architecture,
Mm.
what human brain could have produced these writings. Maybe there's not that many. Then you can resurrect simulacra of these thinkers, and play air hockey with them, like Jimi Hendrix playing air hockey with Abe Lincoln in The Simpsons, right?
That's right. That's right. Or yeah, Philip K. Dick's simulacra. He
Yeah.
brought Abe Lincoln back too. Yeah.
Yeah. That we can build you. Yeah, that was
Oh,
one of
we
the
can build you.
inspirations.
Yeah.
One of the
Yeah.
inspirations for David Hansen building the robot Philip K. Dick, as well as Sophia and Desdemona, all the other robots we're working with now.
Yeah. Over at Hanson Labs. Yeah. That's like the ultimate recursion to me, that like Philip K. Dick wrote about the simulacra and We Can Build You, and then becomes one himself because of you guys. I thought that was fantastic.
It's a shame that he wasn't around to see it, but we will mind upload him into his robot simulation once. But we want
Yeah.
to get the hardware working a little better first. It'd be a very frustrating robot to be uploaded into at the present moment.
Okay. All right. Well, so I wanted to get in on AGI, but I think maybe first I want to talk about just artificial intelligence. Like what is in general, what is intelligence? I have a quote from Hidden Pattern. Intelligence is the ability to work and adapt to the environment with insufficient knowledge and resources. But I think nowadays you're going for Weaver, DR
Yeah, I mean,
Weinbaum's view.
I think like any complex concept, there's a lot of different ways to look at intelligence, which each have their own validity and can be sort of mapped and converted into each other, right? And I
Yeah.
mean, a good analogy is the definition of life in biology. So I mean,
Right.
we don't have a highly crisp definition of life.
Yeah.
We don't really need one, and we can do synthetic biology perfectly well without one, right? So like a
Mm.
virus is sort of life, sort of not life. That's fine. Virologists are not impaired by that
Hmm.
classification issue, right? And
Yeah.
you can do synthetic biology and make weird, nano-engineered DNA computing-based life forms. And whether these are true life forms or half life forms or trans life forms, I mean, it's fine. Thinking about the terminology is mentally stimulating, but
Yeah.
you don't need to have crisp, nailed down definitions of everything, particularly in the natural world, which is fluid and hard to pin down,
Full
right?
of fuzzy things. Yeah. Yeah.
So yeah, I think I mean, intelligence, you could think about a lot of different ways. So from a practical system engineering standpoint, a lot of the time, yeah, you're thinking about it as making a system that can achieve complex goals in complex environments under limited resources. And when you cash that out mathematically, it gets subtle. Like it's broader than trying to maximize expected reward, which is what the reinforcement driven learning paradigm is doing, because
Right.
not all goals can be expressed as maximization of expected reward.
Yeah. And we change goals. We do, at least. Like
Well, yeah,
we
yeah.
let go of goals.
Well, that's right. So one point is a goal doesn't have to be an expected reward. A goal could be like any mathematical function
Okay.
of possible future states or of possible world histories, right? So it
Yeah.
doesn't have to be a sum of rewards,
Okay.
and the measure of a goal doesn't have to be a real number. It could be multidimensional, right? So
Mm.
achieving goals doesn't mean trying to maximize some single number associated with the goal. I mean,
Okay.
achieving a goal could be measured by something in any partially ordered set, which could be a set of paraconsistent logic expressions or complex numbers or whatever it is.
Yeah.
So the notion of achieving complex goals in complex environments under limited resources sounds like it's the same as reinforcement learning, like maximizing expected reward, but it's actually broader, and it's broader in ways that are relevant, because when you get into self-modifying systems and so forth,
Hmm.
then there are various weird hacks that can screw you up with maximizing expected reward. Like, oh, let's just screw around with with my reward maximization circuit so that I'm always blissed out and think I'm maximizing my expected reward, which is what fentanyl or something does, right? So
Right. Yeah.
you
Or the experience
can
machine
hack
or something. Yeah.
so you can hack expected reward maximization in ways that you can't hack more general mathematical formulations of goal achievement.
Okay.
That said, I have emphasized that a little less in my current thinking. So I've always been deeply into complex self-organizing systems, and I was saying for a while, maybe from many perspectives, it's better to think about self-organizing complex adaptive dynamical systems than about AGIs. I mean, of course, what we think of as an AGI is just one kind of a self-organizing complex adaptive dynamical system. But in the end, if you're going to be really adaptive in a great variety of environments, that requires being generally intelligent. So in a way, there are different ways of looking at the same thing. And so Weaver's formulation of general intelligence in his PhD thesis and book, Open-Ended Intelligence, is drawn from the intersection of complex systems theory with continental philosophy, Deleuze and all that. So he's looking at general intelligence as combining the dual drives of the drive toward individuation, like maintaining system boundaries, and self-transcendence. So going beyond your boundaries and moving into becoming something totally different than what you were before. And this is interesting because those two contradict each other in so many cases, right? Like the safest way to maintain your boundaries is not to grow into something totally incomprehensible and beyond your current self.
Yeah.
On the other hand, if you don't maintain your boundaries well enough, you're going to dissolve and you're not going to be able to survive long enough to self-transcend. So these two, there's a tension between them, but also a cooperation between them. But I would say, if you formulate it carefully enough, in the end, this is going to be equivalent to achieving complex goals in complex environments under limited resources, right? Because if you want to keep achieving more and more complex goals, eventually, if you don't self-transcend, you're going to be limited by your own complexity, right? So you have a limited complexity. You can only achieve goals of a certain complexity. In the end, you got to transcend yourself to be able to achieve the bigger goals. But then to balance individuation and self-transcendence, which is tricky. I mean, that implicitly is going to involve solving a lot of thorny sub-problems, which will involve achieving various complex goals in complex environments. So I mean, you can map these into each other, but they're interestingly different focuses, right? So in terms of AGI design, I've been thinking about complex goals. Easy to think about, like, what tasks is the system achieving in what situations? How well can it achieve these tasks? And the open-ended intelligence view leads you more to think about, okay, how is the system, increasing its own odds of survival, and how is it sort of increasing the odds that it can grow into something beyond itself? And in building a system like OpenCog, we're thinking about all of these things, right? We got tasks. We want it to do these tasks. We also are thinking about how can it survive and how can it self-modify and grow beyond itself. So you want to think about these things in a variety of perspectives to build a really sort of robust AGI.
Yeah. So I heard you say this at Mindfest 2023 about the self-individuation, self-transcendence, and I thought, that sounds a lot like Jordan Peterson recounting Order and Chaos, and then I read Weaver's book here, Open-Ended Intelligence, and I saw that he brings up a little bit Jung as well. So there might be that continental Jungian crossbreed going on, and I'm an analytic philosopher, so doing this was quite a quite the task, but I did it for you.
I'm sorry for you. Yeah.
Yeah.
Yeah, actually, so we'll do another podcast once I finish the
Awesome.
Cognitio Philosophicus book. But
Yeah.
part of what I'm trying to do in that book, from a philosophy view, is sort of do continental philosophy in an analytical philosophy style.
Yeah, and you can because you know math and logic, but you also have
Because
read the Continentals.
so I always like the fact that analytical philosophers were formulating things in a rigorous and mathy way.
Yeah.
On the other hand, I also thought the continental philosophers more so got the nature of the universe right. So although their style is an acquired taste, I mean, it's, if you read Deleuze or something, I mean, it's not meant to be fully understood, and they change the meaning of words from one chapter to another because they want to give you this dislocating feeling that you don't know what the hell everything means. So I mean,
Right.
if you just, I mean, it's like watching Twin Peaks, the old TV show or something, right? Like if you're trying to treat it like Sherlock Holmes and pin down the reality, you're going to be very annoyed. If you just realize leaving some mystery there that can't be solved is part of the point, like then you can enjoy it, enjoy it for what it is, right?
Yeah.
And so
Yeah.
so I can appreciate that, but yet for doing things myself, I still tend more toward the analytical style. So yeah, part of my thinking with the Cognitio Philosophicus book I'm working on is, okay, let's take the perspective there is no absolute reality, right? Let's take the perspective reality and mind construct each other. Everything should be within a perspective, including physics and AI and whatever. But let's try to formulate this in a reasonably rigorous mathematical way without fuzzifying the language unnecessarily. That brings you down the road of using sort of non-well-founded set theory, paraconsistent logic, intentional logic. So it brings you down the road of using various wonky math tools that analytical philosophers don't traditionally use, because a sort of naive realist philosophy, which has been more conventional in the analytical philosophy world, just for cultural reasons, right? A realism-driven philosophy, you don't really need paraconsistent logic, which is about how do you manage contradictions in an artful way. You don't really need non-well-founded sets, which is about how do you deal with realities that have no grounding.
Right.
But if you're trying to formalize continental philosophy, then you do need these weird branches of math. But what's cool is that mathematical logic and set theory have been quite adventurous in developing weird math tools you can use to formalize philosophy, and these have been used in analytical philosophy here and there, right? Like situation semantics from John Barwise and so on was using non-well-founded sets to formalize natural language semantics. And there's a few weird papers out there on like paraconsistent logic to formalize ethics and so forth. Right?
Yeah,
So
every now and then Graham Priest will come out with something, or J.C. Beale, and everyone gets all upset, but they're so smart that you can't argue with them. Yeah.
Right. But the mainstream of analytical philosophy has not explored the sort of perspectivism that you got in continental philosophy, and has not, partly because of that, has not tried to leverage the spectrum of set theory and logic tools that are out there. And this ties directly into AGI design, actually, in ways that are hard to explain to people without a math background. But so in my main AGI push now is on a system called OpenCog Hyperon, which is a new version of the OpenCog system. And let me tie that back into the last question you asked to keep some modicum of continuity here. So what is AGI? I mean, went over two different ways of looking at what is intelligence, open-ended intelligence, and then achieving complex goals in complex environments under uncertain resources. So obviously, an AGI is then a designed or engineered, or at least human engineering seeded system
Yeah.
that achieves some high level of general intelligence. I mean, one thing you see when you look at definitions of general intelligence is they quickly point at general intelligence far beyond the human level, right? Like I mean, humans are not that good at achieving complex goals in complex environments. Like we can't run a maze in 700 dimensions. We can barely figure out how to find a mate, right? We're very stupid in many ways compared. We're not good at proving math theorems, right? So it's easy once you start to formalize what is general intelligence. It's easy to see there's going to be far more generally intelligent systems than humans.
Yeah.
Even within the constraints of the known laws of physics, let alone once AGIs
AI
revise the laws of physics as we
AI
currently
XI and
understand them. Yeah, but so building an AGI system, we can think about building a human level AGI system, by which we usually mean a system that's at least at human level in every significant respect, because AI is already beyond human level in some limited respects.
Right.
And you can then also look at, artificial superintelligence, ASI systems vastly beyond the human level. And my own effort to build an AGI for the last decade or two has been centered on a system called OpenCog, which is sort of an attempt to integrate together algorithms and data structures from multiple AI paradigms within a cognitive architecture that's loosely inspired by the human mind. So we're not trying to emulate the human brain.
Yeah.
We are trying to emulate at a high level the way the human mind works. But we're trying to do it by piecing together algorithms and data structures from different parts of computer science and math. So,
and this is what you call cognitive synergy, or a hybridized model?
Cognitive synergy plays in there. And let me get to that. So I think the overall cognitive architecture of human-like minds is kind of well understood from cognitive psychology, and much better now than in the 70s, let's say. I mean, we have a number of kinds of memory in the human mind. We have episodic memory of our life history, like declarative memory of facts and statements and beliefs, procedural memory of how to do things, associative memory of what laterally so it brings to mind with other things, sensory and motor memory. Each of these kinds of memory has its own form of learning associated with it in the human brain. And then one thing that's interesting, in the human brain, the different kinds of learning associated with the different kinds of memory, they synergize together. They each sort of help each other and accelerate each other, help each other get out of dead ends. And this is what I've referred to as cognitive synergy. So what we're trying to do in OpenCog, take the same kinds of memory that exist in the human mind, implement them in ways that work on current computer systems, implement forms of learning associated with each kind of memory that a human mind needs, and then make sure that the sorts of learning associated with each type of memory can synergize and help each other out, right? And move forward together effectively. And so you want to wrap this in a system which is then controlling an agent doing things in a complex world, interacting with other agents. And that's super high level. And in practice, we've done a lot of very specific stuff within that framework. So with declarative memory, we've implemented a probabilistic logic framework to do reasoning on declarative knowledge. For sensory knowledge and motor knowledge, we've been working with deep neural networks. For episodic memory, we've been working with hypervector embedding. So for procedure learning, we've been working with genetic programming, sort of evolutionary program learning. So then the math of OpenCog comes down to how do you make the mathematical algorithmic data structure foundations of these different kinds of learning associated with different kinds of memory. How do you make them all work together, right? And so we built the first version of OpenCog in 2008. We did a bunch of research with it, published papers, did some prototypes, put it behind some commercial software systems. About a year and a half ago, I just decided, like, fuck this, I'm rebuilding it from scratch.
Yeah,
And that was an extremely horrifying and painful decision to
I
come
can
to,
imagine.
because
Yeah,
there's a lot of code there. And I knew, like, this means taking 2 years out from doing AGI R&D and
yeah,
focusing on system building,
right.
which, while fun and challenging, was not fundamentally what we wanted to do, particularly at a time when AI is exploding all over the place, right?
Yeah,
on,
right, man.
on the other hand, we were trying to connect deep neural nets with OpenCog to do neural symbolic and neural symbolic evolutionary learning.
Hmm.
And we could see that the speed at which our reasoning systems could reason was just so much slower than the speed at which we could train neural nets on the GPU server farm. So, like,
Interesting.
if we wanted to make a system that was neural and logical and evolutionary, where they're all connected together within a common architecture,
Yeah.
we needed all the different parts to be able to learn at roughly the same high speed. And I
Yeah.
could see, like, to do that, we just need to rebuild all the plumbing. And that's
Well, how,
so
how do you
we
make the logic component faster, though?
Aha, well, I'm glad you asked. That's a very interesting question. So there's a few different pieces there, right? There's two main pieces to the OpenCog Hyperon architecture. One is a distributed atom space. So the
Yep.
atom space is our OpenCog lingo for basically a large knowledge metagraph. So it's a
Yep.
large graph with nodes and links pointing to links pointing to subgraphs, links with many targets, and it runs across many, many different machines in a distributed way. So we now have a new, quite fast and performant, massively distributed knowledge metagraph.
Is
We
this on
built
a
it.
is this on the blockchain as well?
It interoperates with the blockchain. Yeah.
Okay.
So
Okay.
this is actually built. It's built on top of MongoDB and Redis, actually. So
Okay.
MongoDB stores the nodes and links, and Redis stores the indexes.
Okay.
But so it can interoperate with blockchain in a few different ways. So each machine on in the distributed atom space, each machine can be a node in a decentralized network like SingularityNet or Hypercycle, our new ledgerless layer one blockchain.
Okay.
Also, if you have knowledge which is stored in an encrypted way for use in a blockchain, I mean, we can of course store that in the distributed atom space, and you can sign like a subnetwork with it within the atom space with appropriate keys.
Okay.
So it's designed so you can use it on or off chain, and it's kind of how it has to be, because you're always going to be able to do things much faster if you can wrap a bunch of machines in a firewall and just assume everyone is safe to see everyone
Yeah.
else in that firewall.
Yeah.
On the other hand, sometimes that's not your situation,
Yeah.
and you really want to deal with encryption between two different nodes in your distributed atom space. And
And
for
that's your whole
that,
thing is
we integrate
distributing it across. Yeah, distributing it so that no central
Yeah, yeah.
element could take it or anything like that
Well,
and destroy the world.
that's true, but it comes down to a complex architecture, because
Okay.
if you have a server farm with 100 servers on it with a single owner, I mean, you can assume that whole server farm is a trusted network,
Okay.
and then you have a proxy to that network, and the proxy to that network deals with encryption in and out. But within that server farm of 100 machines, you can assume it's a trusted network, which means things can go very fast.
Okay.
Or you could have a server farm where each machine is owned by a different person, right?
Yeah.
And then you're using encrypted communication,
And
and
that's
you're
much
using
slower.
you're using our
Okay.
Hypercycle and SingularityNet tools there, and it's a bit slower. Now,
Okay.
the reason we're developing Hypercycle, which is our own layer one blockchain, is to make it not that much slower, right? So we
Okay.
developed a blockchain that gets rid of the replicated ledger.
Yeah.
Having this ledgerless blockchain lets us do, encrypted on-chain AI communication and computation much faster than you could do on conventional blockchains. But
Yeah.
even though it can be 10,000 times faster than the regular blockchain, it's still a bunch slower than not having to encrypt stuff at all. Like, I mean,
Yeah.
doing all the encryption and decryption is it's always going to give you like an order of magnitude slowdown or something, right? So,
Yeah.
I mean, sometimes you need to do it, sometimes you don't need to do it. But
Okay.
so the other key component of OpenCog Hyperon as a software system is a new programming language we're developing called
Meta type talk, right?
called Metta, Metta, and
Yeah.
that name was sort of a bad Buddhist pun because Metta is meta type talk, but
Yeah.
metta in Sanskrit is also loving kindness. Like
Yeah.
many of
Right.
us have done like metta meditation, where you can like
Yeah.
it's related to similar to Tonglen meditation, where
Yeah.
you like breathe in the bad and breathe out the good, and transform the universe into a happy, beautiful, loving place.
Yeah.
Right?
But then the
So
metaverse came through, and now it sounds in
yeah,
speech.
now
Yeah.
it sounds like Mark Zuckerberg, but Mark Zuckerberg needs peace and love just like
That's true.
everybody else.
That's
So
true.
it's fine. Yeah, we love you, Mark. Yeah.
Yeah. Yeah.
Even though we don't like your product much, but yeah.
Yeah.
So
Yeah.
so the meta language we've designed as a very, very abstract programming language. So I mean that the semantics is based on cubical homotopy type theory. So we've gone a lot into like having the most abstract possible version of equals. So you could support many different logics that deal with equality in
Oh,
different
yeah.
ways.
Okay.
So the idea behind Meta is really the language should be as abstract as we could possibly figure out how to make a language. So you can then create many type systems within Meta, which embody pretty much any programming language or any logic that you can think of. Right now, of course, Gödelian constraints mean you can only go so far in that direction,
Yeah.
but
Sure.
we've gone very far in that direction, right?
Okay.
So you can do non-well-founded sets, you can do pair-consistent logic, you can do infinite order probabilities and higher order quantum types.
Yeah.
You can
You got
do pretty
fuzzy and
much
intuitionistic in there
yeah,
too.
yeah, of course.
Yeah.
But,
Yeah.
so you can do pretty much any form of logic or any programming language semantics. You can implement this as a type system within Meta, and this is intended so it will let us express these very abstract sort of continental philosophy-ish subjectivist ontologies
Yeah.
directly in Meta, but it also will let the system invent its own logics, right? Because maybe the logic we gave it isn't best. Maybe it needs a different axiom system. We don't want it to have to rewrite its own plumbing then. So
Yeah.
then the master stroke here came from a collaboration with a guy named Greg Meredith, who lives not far away from me here in Seattle area. Now, he had developed a programming language called Rolang
Hmm.
for use with the R-chain blockchain, which he had developed. And Rolang was based on a formalism called the Rho calculus, which is it's a modification of the pi calculus, which is a process calculus for managing distributed processes.
Okay.
So if you this gets a bit mathy, but if you know what the lambda calculus was sort of the initial formalization of logic for computer science. It's a very abstract formalization of variables and bindings and so forth.
Yeah.
But it's kind of designed for sequential processing. If you have a distributed network, then you have to deal with the case where a variable could be bound to values that live at different locations in the network.
Okay.
And that leads you to the pi calculus, the process calculus. Now, and so then you have a notion of communication channels between variables and their bindings on the network.
Yeah.
Now, what Greg's row calculus does, it makes that recursive. So it lets you quantify over communication channels in that process calculus network.
Yeah, I was going to ask about recursion because I haven't heard anything yet about that actually. So
right. So Greg has a fully recursive, reflexive, Turing complete version of the distributed process calculus. He used that to make a programming language for smart contracts in the R-chain blockchain.
Okay.
So what we're doing now, we're working with Greg to modify his Rolang interpreter to be basically part of the plumbing for our Meta language. So we can, when we want to compile Meta for rapid execution, we compile Meta to Rolang. We run it on the new version of Greg's Rolang interpreter. Now, the Rolang interpreter, due to the properties of the Rho calculus, it allows a great variety of algorithms to run with linear speed up on a GPU or other parallel processing infrastructure.
Yeah.
So we can take most algorithms we want to deal with, implement them in Meta in a very abstract way, compile Meta to Rolang, then the Rolang, our calculus interpreter, it will run these on, say, a GPU with 1,000 processors in a way that gets roughly 1,000 times speed up. So then,
okay.
so this gets back to your question. Like,
Yeah.
we can make this very abstract, general stuff, including logics in all sorts of different logic formalisms. We can make this really fast using the row calculus formalism, and this gets into the whole algorithmic infrastructure of big tech. Like, every big tech company now is based on MapReduce. MapReduce being a certain way of boiling down algorithms to run fast on a bunch of GPUs, right?
Mm-hmm.
And however, if you look at the algorithms you need for AGI, these don't work well for MapReduce. So you need a more sophisticated way to boil your algorithms down to run efficiently on GPUs, which is the most efficient compute architecture we have now. And Greg's row calculus does that, right?
Okay.
Which is quite interesting. Now, in the neural net world, they're doing fine with MapReduce because they're not doing recurrent neural nets too much.
Yeah,
Like,
just feet forward. Yeah.
transformers have a limited amount of recurrence, but if you got into more richly recurrent neural networks, which I think you do need for really abstract creative cognition, if you go to recurrent neural networks, you're going to get things that are irritating to parallelize using MapReduce.
Okay.
And you're going to want something more like Greg's row calculus also.
Yeah.
So I mean in implementing the plumbing of OpenCog Hyperon, we're diving quite deep into, how do you use mathematics, computer science, advanced programming language implementation to create a really efficient way to run neural nets, logic systems, evolutionary learning, other sorts of AI all together on large knowledge graphs that run efficiently in modern GPU infrastructures. We're in the middle of that. I'd say by the end of this year, beginning of next year, we should be far enough through that we shift more of our effort to building AGI on this infrastructure.
Okay.
Right? And I mean, we're playing with that now. We're doing logical inference in OpenCog Hyperon. I mean, we're already, and we're doing some episodic memory stuff behind the Grace, Sophia, and Desdemona humanoid robots in OpenCog Hyperon. So on a sort of experimental basis, we're playing with parts of the system in some real stuff now.
Yeah.
But it's looking like probably early next year before it's really ready for prime time.
Okay.
Once we get there, there's really two separate projects that I'm putting a lot of energy into. One is coming up with the next thing beyond ChatGPT by adding logical reasoning onto ChatGPT.
Okay.
Or onto LLMs that are.
Would that have recursion in it?
It would have recursion on the logic side,
Okay,
but
cool.
not on the neural side.
Right. Yeah. Naturally.
So that's a bit of that system, in a way, is a bit of a hack job. On the other hand, if you can take a logic engine and hybridize it with a large language model in a way that makes the large language model more capable of multi-step reasoning and more able to ground its utterances in reality.
Yeah.
I mean, this will be incredibly huge from an economic and practical standpoint, right?
Yeah, and look much more like actual thinking and the
it
G factor.
It will. It will. It doesn't get you all the way to AGI, but it's something.
Yeah.
Then the other thread that I'm looking at is taking OpenCog Hyperon to control a population of little virtual agents running around in a virtual world and basically building stuff together collectively, creating their own communication methods.
Yeah.
So we're playing with agents in Minecraft now.
Okay.
We're going to be working with our own virtual world, which is called the SophiaVerse Metaverse.
So it is happening. That's great. Yeah, you are making
SophiaVerse will happen. Yeah.
That's crazy.
That has its own business model associated with it, but the aspect of it that interests me most is using it as a sort of playground for baby AGI agents. So I think that's important. I mean, it gives you social learning and grounding and embodied learning in a way that the logic enhanced LLM doesn't. but the logic enhanced LLM can get to like massive adoption and practical functionality very, very rapidly, right? So I think that also has a big role to play.
Well, that's one of my favorite things that you talk about is like training a baby AGI, especially with like moral components. And you say like, well, look at the ones that we already have now, or look at the AI systems we have now. Usually they are learning how to gamble, or they're learning how to sell people stuff they don't want. But if we want to have like moral AGIs, maybe we need to take them by the hand, metaphorically or whatever.
Well, what's interesting about morality and LLMs is just how good modern LLMs are at emulating human moral judgments as they are at this moment, right? So, I mean, if you you can take, and this is a big difference between GPT 3.5 and GPT 4, actually.
Okay.
So, if you take a variety of ethical puzzles, just describe a situation and ask an LLM, like, my friend John is a very ethical, compassionate, justice-minded individual. What would John say about this situation? Who's right? GPT-4 is very, very good at guessing what ethical judgment a person would make, right? And this is interesting. It's not terribly surprising in that ethical judgments they're not that deep in terms of reasoning, right? Like most ethical reasoning it's not like a science paper with multiple different steps, because that usually requires a certain crispness, or the noise blows up a lot. Okay. Ethical judgments are fuzzy and hairy, and things are not well defined, which usually means you can only do very short chains of reasoning. And very short chains of reasoning, GPT-4 and other LLMs are not so bad at, right? So it seems like if you wanted a like people's court thing where you just want to know like what would a random jury that was reasonably fair-minded say about this ethics situation, I get the feeling current LLMs, they might do better than a random jury, actually.
That's fascinating.
They're not actually terrible at it. Now, when you get to self-transcension versus individuation, there you're hitting a problem, right? Because, I mean, human ethics is not the same as it was in 1950, right? I mean, even in the early 70s, when I was growing up in suburban New Jersey, so I was born in Brazil. When I was a young kid, we lived in Eugene, Oregon, surrounded by beautiful pot-smoking, commune-living hippies. Then in second grade, the tragedy happened. We moved to suburban South Jersey, right? And what I found in suburban South Jersey, like my mom was gay and we were Jewish, and you would get the shit beaten out of you for these things. So we got we got our car turned over, we got the windows in our house broken. I mean, so this was standard suburban American ethics in the mid 1970s, right? Like, if you're gay, you get the crap beat out of you, right? And now in most of sub-Saharan Africa, if you're openly gay, you'll get beaten to death, right?
Yeah.
But in Seattle area where I live now, you can be openly gay, walking down the street, holding hands with your partner, whatever gender they may be. Not to say you could never run into a problem, but it's a pretty accepted part of life, right?
It's a little bit different than Clayton, New Jersey.
Yeah, so that's an evolution though, right? And the thing is, that evolution happened because of depths of the human mind and heart that a GPT-4 doesn't have. So the GPT-4 can parrot back the ethics of this moment by sort of matching each situation into a variety of other situations that occur in its training database.
Right.
And there's a lot of them, and the reasoning isn't that deep and multi-step. But the evolution whereby we're transforming ourselves into better and better people and into a better and better society, this ethical and moral evolution is something these systems are not capable of, which relates to, in general, how these systems simulate general intelligence without having it, right? Because
just have a huge, gigantic training.
They can't extrapolate that far beyond their training, But fuck it, they don't have to because their training is
It's
everything
huge.
on the web, right?
Right,
So,
right.
and I mean, so yeah, that's it means that they can be very general relative to an individual human
Yeah.
because their training database is more stuff than any of us can fit in our brain.
Yeah,
So they
so
can
why I
be,
think that we'd have good intuitions about what that would look like.
yeah,
Yeah.
we don't have a good intuition about how something will work with such a huge training data set, but we're gaining that intuition now by playing with the systems, and
Yeah.
I think these systems are a big breakthrough in the sense that they can probably, after a few more improvements, they can automate away 80% or more of jobs that people now do,
Yeah.
because most jobs people now do are also just recycling of stuff that was that was done before, right? So
Yeah.
on the other hand, I think they can serve as a component of AGI systems
Hmm.
because even though they're not human-like in many respects, they're interesting and they're smart in some ways. So why not use
Yeah.
them as a component of AGI systems? But they're missing some key things that you need to be a really human-like AGI, and the view of general intelligence as open-ended intelligence hints strongly at what's missing there, right? Because
Yeah.
they're not able to fundamentally self-transform.
Yeah.
They don't have the reflection nor the abstraction that you need to drive fundamental self transformation. So yeah,
Yeah.
now
Autopoiesis. Yeah. Yeah.
yeah,
The
yeah,
Continental something.
they're not autopoietic systems. They're not self-organizing complex systems in a very strong way, although they can host some interesting complex self-organization, which makes things tricky. Like if you look at what's happening with few shot in context learning in an LLM, this is learning that doesn't involve modification of any of the weights. It's only learning in the activation space. And there
Huh.
is some autopoietic self-organization in the evolving activation vector in the network when it does few shot in context learning, which is quite cool. But it's all within the context of this vast fixed weight matrix, right? So it's quite funky. I mean there are quite validly interesting things in there, but they're in a weird context that in itself can't directly be grown to AGI. But I think they're also a lesson of what can happen with scale, right? I mean, not
Yeah.
that scale is all you need to get to AGI,
Yeah.
but they're a lesson that you can take stuff that was moderately interesting at a smaller scale, and when you jack up the scale, it becomes dramatically more functional and dramatically more interesting, right? And
Is
so
there still like a frame problem at every scale? Like if there's a scale, isn't there still like a frame problem of there's something outside this frame that it doesn't know about if it's not able to like generalize and self transcend past its.
yeah, certainly. I mean, it can't go beyond its training data, and humanity is inventing new things, and the natural world has many things that none of us have discovered, right?
That's
So,
true. Yeah.
I mean, yeah, I mean, in theory, if you train an LLM on the entire physical universe and everything that occurs within it, then maybe
Yeah.
that would be all you need
Laplace's
until
demon or something. Yeah.
until you discover a new theory of physics and realize the physical universe isn't all there is or something,
Yeah.
right? So,
Right.
well, I
Amen.
mean, yeah, in practice, I mean, LLMs now can't write a new science paper
Hmm.
because science is all about going beyond your training data, right? Science
Yeah.
is about taking multiple steps of rigorous yet speculative reasoning that bring you well beyond where you were before, and that's not done. But that's not what this kind of system
Yeah.
does. For the same reason, these systems can't invent a new genre of music or literature or
Oh yeah.
something. These are about taking a big leap beyond what was there before. But still, one of the many lessons there is like, okay, then what happens when we take a logic system or an evolutionary learning system and just give it way more processing power and way more data than what it had before? Like you can see familiar algorithms start to do unfamiliarly cool things when you
Yeah.
feed them massively greater scale, right? And we can
Yeah.
do that with things like the new OpenCog system, we can also do that with new forms of hardware, like I'm working on with Rachel St. Clair, who you
Yeah.
name dropped earlier, where we're working on an AGI board with a custom OpenCog chip and Rachel's custom hypervector chip, right? So I think we can have new forms of hardware, new classical hardware, new probabilistic and quantum hardware. But even using the current hardware, I think we can make more and more AI algorithms that are already known do amazing new things just by jacking up the scale, and fostering that is part of why we're rebuilding OpenCog for greater scalability. So yeah, I find myself in what seems like a perplexingly unique position now. In that it seems like, so I believe LLMs can be part of the key to AGI. I believe
Sure.
they're not the whole key to AGI. I believe, given what LLMs can do now, the shortest path to an AGI will be to hybridize LLMs with other sorts of AI, such as logic, which adds a reality groundedness and a reasoning ability LLMs don't have, and such as evolutionary learning, which adds a creativity that LLMs don't have.
Yeah.
So if that's true, I mean, in OpenCog, we have by far the best framework for integrating together different AI paradigms, far better than big tech has, because they just haven't been focusing on that. And the knowledge graphs that Microsoft and Google have, they don't have variables and bindings in them. They don't have meta knowledge in them. They can't represent general programs. They're way lamer knowledge graphs than what we have in OpenCog. They're very simplistic, right?
Okay.
And on the other hand, we also have a way to deploy this sort of integrated multi-paradigm AI system, glomming together LLMs with other things. We have a way to deploy this on the blockchain in a decentralized way, and we're now working with people running server farms in Paraguay, in the former Soviet bloc, in Asia, and in US, everywhere. So we're working with people running crypto mining farms and repurposing their infrastructure to run OpenCog Hyperon clusters. So we have a reasonable roadmap to, during the next couple of years, deploy what's going to be by far the world's smartest AI system, way beyond ChatGPT, and deploy it in a decentralized way on server farms and machines, in Paraguay, Turkmenistan, and US, and Ethiopia, and everywhere you can think of, right? And so that was a very interesting opportunity to take the next step toward a singularity, and also take it in a way that's fundamentally globalized, decentralized, and controlled by DAO type governance structures rather than by centralized governance or companies, right?
So Ben, I got to ask you a couple philosophical questions about this, because my audience is mainly philosophers and theologians. So some actually, a practical one first is the decentralized model of Hyperon. Seems really cool if you look from like a libertarian perspective, where you're like, man, screw these big governments. I don't want them getting a hold of it. It's great to be decentralized. But then you do assign a non-zero probability that things could go wrong. And if it's distributed, there's like no kill switch, it seems like.
So I'm first of all, definitely I'm more anarcho-socialist than a political libertarian.
Okay.
So I'm
Oh, you wrote a manifesto. Yeah, that's right.
I mean, I am inclined toward opposing unnecessary regulations.
Sure.
So I was a bit disturbed that in the US now, the mainstream media outlet most amenable to my views on AI is Fox News, which was kind of funny because mean, I'm really left wing in most ways.
What
On
a
the
weird
other
time
hand,
to be alive. Yeah.
I mean, I'm not in favor of heavy regulation of AI, nor am I in favor of banning cryptocurrencies and stuff, right? So on some of these things, I'm actually aligned with the current right wing more than the current left wing, within the very narrow scope of U.S. politics, right?
Sure.
But I do tend toward anarchism, more in the Kropotkin sense of, like, when you stop being top-down assholes about things, mutual aid will often rise to the fore, right? And I think I have more faith in that than in big government and big tech to effectively mediate the transition to superhuman AGI. So you talk about the kill switch. I'm more worried about the other kind of kill switch that, you know, Trump, Xi Jinping, or Putin used to push the button to make the AI kill their enemies, right? I mean,
Yeah, totally.
that kind of kill switch exists,
Yeah.
and there's increasing propensity to use it, right? So,
Yeah.
I mean, that the thing is, it goes back to Winston Churchill's maxim that, you know, the democracy is the worst possible system of government, except for all the others that we know about, right?
Right.
So
Right.
that I think there is a risk to having the emerging AGI governed by a decentralized democratic network, just like there's a risk in having it be open source code, right? I mean,
Yeah.
there are risks there. You can't deny those. On the other hand, what's the risk of having military and intelligence, and then, you know, amoral advertising companies control the first AGI, right?
Yeah.
I mean, there's a big risk there also. So balancing those risks, you know, it's not a science. We don't have a mathematical calculated way to balance those risks. I guess my heart-driven way to balance those risks says, like, I'm going to trust the vast chaotic mass of humanity
Mm.
over these self-appointed elite groups of companies that are working closely with intelligence and military organizations,
Yeah.
right? And
Yeah.
I mean, and I think there is some data-driven backup for that, in the sense, if you look at humanity as a whole right now, there could be so much more horrible terrorist activity on the planet than there is, right? So I mean, if if you had the amount of energy underlying, you know, OpenCog or Google DeepMind going behind the, you know, the job of using modern technology to kill as many people as possible,
Yeah. Terrorist
you'd have a
LLM
lot.
or something. Yeah.
Yeah, you'd have a lot of, if instead of open AI, you had like open kill people, right? Which doesn't have to really be open either. Open AI isn't open, right? So
Right.
I
Right.
mean,
Yeah.
so the thing is, we have a lot of capability for bad things on the planet right now. It's mostly actually not manifested
Mm-hmm.
because, for a combination of cultural and psychological reasons, the combination of technical ability, organizational ability, resources to deploy advanced technology to do things, it's sometimes deployed for the good of humanity. It's sometimes deployed to make this or that guy money.
Yeah.
So it's sometimes deployed, you know, to work for the provincial good of one tribe or country or another. It's not very commonly being deployed just for purely like chaotic evil purposes of
Yeah.
just annihilating everyone, right? So
Yeah.
I mean, so you can, I mean, you can at least see empirically that that's how it's gone so far. So that,
Yeah.
I mean, whereas advanced technologies in the hands of governments have reliably been used to make weapon systems to try to kill their enemies, right?
Yeah. Yeah.
So I think there's some qualitative reason to place faith in the vast teeming mass of humanity. Like, I think the internet and Linux, which have been developed in an open way, on the whole, I feel like have been sources for good rather than evil, and
Yeah.
have crossed boundaries more than created boundaries, right?
Yeah.
But there's no guarantee what one way or the other, and
Yeah.
I think that's just the way it's going to be. I'm relatively comfortable with that. I guess I don't believe there's any absolute reality anyway. And if you take a sort of transnihilist Nietzschean point of view, like every breath you take, literally, you're taking a plunge into the great unknown. We just shield ourselves. We shield ourselves from that, you know, for psychological comfort. But that's, I
Yeah.
mean, we have no solid knowledge that we're not brains in a vat, and every moment we're just going to wake up and be like, oh shit, that was a weird dream, but this is
Right.
the actual reality, or maybe it isn't, right? So
Yeah.
I
Yeah.
mean,
Yeah.
I sort of live with that all the time, because that's just my way of thinking. I read too much philosophy and took too many psychedelics to
I'm with you.
feel like I'm in a solid absolute reality. I always feel like I'm plunging into the great
Yeah.
unknown.
Yeah.
But I can see for many people, they don't have that point of view. They want to know what's going to happen with a certain solidity going forward. They felt that way for much of their life, and the singularity is not going to be like that, right? And the disruption we're seeing now from ChatGPT is just a little hint of the craziness that's gonna unfold in the next decade.
Yeah. So this one's randomly just for me. So I thought at first when I heard you talk about OpenCog Hyperon, I thought you were saying Hyperion and like the Titan Greek of mythology or the
It
tallest
is
redwood.
Hyperon, which is an
Yeah.
elementary particle,
Yeah,
actually.
strange.
Yeah.
It's got what is particle physics, right? With
Yeah,
strange quarks, but no
yeah,
charm.
because the OpenCog, the main knowledge structure is the atom space, right? So we
Okay.
already had we had
Okay.
a physics metaphor of atoms. So
Nice.
I figured we'd roll with particles. And then the next version of OpenCog after Hyperon will be OpenCog Tachyon. So
Nice.
that will be that will be the quantum computer or quantum gravity computer version that
Okay.
finally goes back in time
Yeah.
to implant the seeds of the singularity in our brains, right?
Yeah.
But
Well,
speaking of going back in time,
yeah.
I've actually got to go. I had a call like 7 minutes ago. I've got to
Oh,
go
sorry
back
about
in
that.
time.
Yeah,
Got to go back
we'll
in
have to
time
do
and
this
do
again.
that.
This was fantastic. Thanks so much,
Definitely.
man. Yeah, there's we got to talk consciousness and Hyperon, all sorts of other stuff. Ben, thanks so much for your time, man. This has been great.
Yeah, this has been great. Yeah. We can go into consciousness. We can go into consciousness next time. Since I'm a panpsychist, my view on consciousness is very boring. I think everything's conscious anyway. So
No,
we're done.
it's fascinating. The patternism, man. I want to get in. I want to talk to
Yeah.
yeah, it'll be
No,
good.
I mean, what will be the states of consciousness of these different AGI systems that we create, and how they can go beyond human consciousness, and how fusing with them can bring us beyond our habitual states of consciousness. I mean,
Yeah.
this will be a good thing to dig into next time. But
Awesome.
I got to run now.
Yeah.
So,
Sounds good. All right, man. Yeah, I'll talk to you
all
soon.
right. Thanks a lot.
All right, folks, that's going to have to do it for now. Ben has been really generous with his time. I hope that he comes back on like 100 times. I could talk to him forever. He's got so much to say. He's got so many areas of expertise and interests. He's fantastic. I really enjoyed talking with him. Ben, please come back on, man. ASAP. If you guys like this podcast, again, please do support me and my efforts here. You can support me on Patreon for a bunch of different levels of support. You can support me on YouTube members, and there's perks with all that stuff. That would be awesome. That would be really huge. If I'm in your top 5 favorite podcasts, please consider supporting me. All right, folks, that's going to have to do it for now. This has been Parker's Pensées, and as always, all glory to God.